Hello friends, welcome to our channel Aha Zindagi Edu-Care. In this lecture, we will discuss about associative laws, which is a part of laws of algebra of sets. So we will discuss what is associative laws and will try to prove associative laws. Okay. So, what are associative laws? Suppose A, B, and C are three given sets. Then, according to associative laws, A union B union C will be equal to A union B union C. Okay? And A intersection B intersection C will be equal to A intersection B intersection C. That is, union and intersection of sets are associative. Okay, so you can prove this using Venn diagram. You have to do, first make a Venn diagram of LHS and then make a Venn diagram of RHS and then try to overlap the two Venn diagrams. When it completely overlaps, that is, Venn diagram of LHS and RHS are same, then you can say that both are equal. Okay, or else you see how we can prove this. So one by one we will prove. So we have to prove A union B union C equal to A union B union C. Suppose you have been given two sets X and Y. Okay, and you have to prove that set X is equal to set Y. What you have to do? First prove that set X is a subset of set Y, and then prove that set Y is a subset of set X. Okay, then we can tell that set X is equal to set Y. Similarly, here we can do the same. That is, if we can prove that LHS is a subset of RHS and RHS is a subset of LHS, then it will be equal. Okay. So, what we will do? Suppose X be any element of A union B union C. Okay. So, we can write X is an element of A union B union C. Union means or. So please remember, union means or and intersection means and. Okay. So we can write it as X is an element of A union B, or X is an element of set C. Okay. Again we can break this one. So we can write X is an element of set A, and this union we have to write or. X is an element of set B, or X is an element of set C. And this again we can rearrange. So we can write it as X is an element of set A, or X is an element of set B, or X is an element of set C. Okay. After rearranging, we can get this. So this will be X is an element of set A, or X X is an element of B union C, because this or we will convert to union. So X is an element of B union C. Now if this or we write as union, then it will be X is an element of A union B union C. Okay. So you may notice that we have started with X is an element of A union B union C, and then we concluded that X is also an element of A union B union C. So we can say that this is a subset of this one. So A union B union C is a subset of A union B union C. So this is our equation 1. Similarly, can't we prove that this is a subset of this? Okay, we have to proceed in same manner. Similarly, we can prove that A union B union C is a subset of A union B union C. Okay, this is our equation 2. So from 1 and 2 we can conclude from 1 and 2 we can conclude that A union B union C is equal to A union B union C. Why we have written this? Because if we treat this as set X and we treat this whole as set Y, so we have proved that X is a subset of Y and Y is a subset of X. So both sets will be equal. Similarly, we will try to prove second relation, that is second law. So here A intersection B intersection C is equal to A intersection B intersection C. So in the same manner we will prove. So here also we are assuming that X be any element of A intersection B intersection C. Okay. So X is an element of A intersection B intersection C, and this we can write as X is an element of set A, or X is an element of B intersection C. Sorry, this will not be or. Always remember intersection means and. Okay, and X is an element of B intersection C. So this we can write as X is an element of set A and X is an element of set B. Again this intersection we will write and X is an element of set C. So after rearranging we will get X is an element of set A and X is an element of set B and X is an element of set C. So this we can write as X is an element of A intersection B and X is an element of set C. From this, X is an element of A intersection B intersection C. Okay. So here also you can notice that we have started with X is an element of A intersection B intersection C and concluded that X will also be an element of A intersection B intersection C. So we can say that this is a subset of this. Therefore, A intersection B intersection C is a subset of A intersection B intersection C. This is our equation number 1. Similarly, we can prove that A intersection B intersection C is a subset of A intersection B intersection C, and this is our equation number 2. So from 1 and 2 we can conclude that from 1 and 2 we can conclude that A intersection B intersection C is equal to A intersection B intersection C. Okay, so this is how we can prove a relation between sets. Okay, friends. So in this lecture we have discussed about associative laws and we have also seen the proof of the associative laws. Okay, friends. Thank you.